In modern mining operations, crushing and grinding are the most energy intensive processes, and it almost accounts for around 50% of the mine's total energy consumption. So as a result of this, we face extensive energy usage, reduced throughput, higher maintenance cost, and increased carbon emission. To tackle all of these challenges, we have made a digital twin model where for the grinding and the crushing system, where each component is digitally represented and monitored in real time using the IoT sensors. So to explore a part of the system, let's take the motors, and we can see the speed of the motors, and if we see the spring, we can see the parameters of the tension of the spring, and the feed motor, we can see the motor speed, temperature and the uptime. For the conveyor belt, we can see the real-time data such as belt tension, pulley and the rotational speed. Another important part of our platform is the AI stimulation engine. With this engine, the users can modify the input variables like hardness, the feed size and the moisture content to observe the real-time effects on the system. And for instance, let's take a motor and increase the hardness, and we see the effect of the motor speed. And similarly, if we adjust the feed rate, the grinding speed increases, and this recalculates the parameters and maintains and predicts us how the system is going to perform in the future with the different variations in the hardness or the feed rate and the moisture content. So these enables the predictive maintenance, and the users can predict the failure even before it's caused, which reduces the operational costs when it's integrated with the stimulation tools like ANSYS, and it can be designed and optimized with the performance. So here comes our energy management dashboard. So to further minimize the environmental carbon footprints, our system has integrated the renewable energy resources, specifically the solar and the wind power, into the commutation process. As the solar and the wind energy being stored in the battery, we can use the grid power when it's absolutely necessary. So we have the total demand and the total renewable supply and the 24-hour power forecast and the energy flow, where we have divided the demand, how the demand is being splitted into the wind and the solar and the grid power. So if we select a particular time, so let us say if we select 12:40 p.m. and if we select that, we can see how much of energy is being used in that particular time. By combining the AI-driven optimization, the real-time monitoring, the renewable energy integration, so we make the whole process more efficient and environmentally responsible. The digital twin that we have enabled into our system makes it very user-friendly, and the AI predictions that predict the failures that is going to occur even before it ruins the system. The solar and the wind power energy that reduces the dependency of us into the fossil fuels by updating the solar power every 15 minutes using the geolocations and the weather patterns. We predict the solar availability, and this all together makes the sustainability and technology work together. Thank you.